Today's lesson is 9-7. We're going to solve quadratic equations by using square roots. A radical expression is an expression that contains a radical sign. Here, this is what's called an index. It's understood too if nothing's there. This is the radical sign, and the number inside the radical sign is called the radicand. You do not actually have to write that. The square root property says that if x squared equals n, that x equals plus or minus the square root of n.
And you do need to write down what's in the box.
Because when you take the square root of a positive number and the sign of the square root is not indicated, you must find both the positive and negative square root, and this is indicated by the positive and negative right here. So this little sign means positive square root and then negative square root. Again, like I said, take a minute, make sure you write down what's in the blue box up here. Alright, we're going to look at this first example. You don't have to write it down. We just kind of want to show how this is going to work. It says x squared equals 9. Just like the opposite of adding is subtracting and the opposite of multiplication is division, the opposite of squaring something is taking the square root of it. It's an opposite operation. So here, if I want to know what x is, I need to get rid of the squared. So to do that, I'm going to do the opposite operation and take the square root. Now I have to again use this plus and minus. So my square root and my squared right here are going to cancel, and then I have plus or minus the square root of 9. Well, the square root of 9 is 3. So my answers are positive 3 and negative 3. And the reason that this works is because whenever we square a negative, we get a positive. If you look at the check here, if I put in negative 3 for x, negative 3 squared is a positive 9. If I put in 3 for x, 3 squared is also a positive 9. So it does have two answers, negative 3 and positive 3. Again, that's kind of what I just said right here. Finding the square root is undoing the squaring. It's, again, an opposite operation, square root and squaring.
All right, go ahead and get down number 1. X squared equals 169. And again, like we said, the opposite of x squared, the opposite of x squared is going to be the square root. And so we have to take the square root of both of these, and we have to say plus or minus in front of our second square root there with the 169. So now I'm just going to type this into my calculator. My square root sign is right here, so I can just say square root of 169, enter, and that's going to give me 13. So that means that x equals plus or minus, positive or negative, 13. So I'm going to write my answer in the brackets, negative 13, comma, 13, because either of those answers will work. I'm going to show you the check on the first one. If I plug in a negative 13 for x equals 169, negative 13 squared is going to equal a positive 169. If you're not sure about that, just type it in your calculator in parentheses, negative 13 squared, 169. And then positive 13 squared equals 169. Positive 13 squared again in my calculator, 169. So both of those check. Make sure that you have that down before you move on to number 2. All right, there's something very slightly different here about number 2. Go ahead and get this down. You have 2x squared equals 242. The first thing we have to realize here is that our x squared is not by itself, so we can't just take the square root of everything on this side of the equal sign. We have to go ahead and get our x squared by itself before we can take the square root. So that means we're dividing everything in the problem by 2 to get our x squared by itself. That cancels and leaves us with x squared equals, and then 242 divided by 2 is going to give us 121. So now our x squared is by itself. Now we're able to go ahead and take our square roots. So we have the square root of x squared equals plus or minus the square root of 121. So this square root of x squared gives me x. The square root of 121 is 11. So that's going to give me plus or minus 11. And in my squigglies, it's negative 11, comma, positive 11. We are not going to look at the check. Unless you want, do you want me to go do, okay. It's the same as the last one. Just know that if you plugged in a negative 11 or a positive 11, it's going to check out. Make sure that you have that down before you move on. All right, so go ahead and get down number 3. It's 16x squared equals 49. So the first thing, again, we need to realize here is that our x squared is not by itself, and this 16 is not being squared. It's just the x that's being squared. So we don't take the square root of the 16 because it's not being squared. So we have to divide both sides of the problem by 16. This is going to cancel and leave us with x squared equals 49 divided by 16 is, we're going to leave it as a fraction, because if I type it in, 49 divided by 16, it's going to come out to be an ugly decimal. So we're going to leave it as a fraction, 49 divided by 16. And when you get really good at this, you might be able to recognize that both the 49 and the 16 are actually perfect squares, so that really bodes well for us with trying to take the square root of that fraction. So we are going to now take the square root of x squared and the square root of 49 over 16. So x squared gives us x when we take the square root, and 49 over 16. 49, the square root of 49 is 7, and the square root of 16 is 4. Sorry, I thought the calculator was there. So I'm going to write that as 7 over 4. So I can say plus or minus 7 over 4. So in my squigglies, it's going to be negative 7 over 4, comma, 7 over 4. Make sure that you have that down before you move on. Just as a side note, if you didn't break it down into 2 steps and you typed it in your calculator, the square root of 49 over 16, it would still give you 7 over 4 without you having to redo that fraction. So if that saves you some time and you can remember to do that, it's fine to do that as well. It will give you the right answer. All right, go ahead and get down number 4. It's x minus 12, all in parentheses, squared, equals 9. So the key here is to realize that not only is my x squared here, but my negative 12 is squared as well, because it's all in parentheses and it's all being raised to the second power. So this one's different than any of the other ones that I've done, because here I'm going to have to go ahead and take the square root of this and the square root of this. So that's going to give me x minus 12 equals positive or negative, and the square root of 9 is 3. So obviously I have not yet solved for x because x is not by itself. So I can do this 2 different ways, but I'm going to choose to do it this way. I'm going to go ahead and add my 12 on both sides. And that's going to give me x equals 12 plus or minus 3. This cancels. And here I have x equals 12 minus 3. That's going to give me 9. And 12 plus 3 is going to give me 15. I could have set it up as 2 separate problems here. X minus 12 equals 3. X minus 12 equals negative 3. And then added my 12 on both sides, which would have given me x equals 15 and x equals 9. Either way would have worked. My answer is still 9, 15. And that's what I'm going to put in the squigglies.
You guys notice this time our answers aren't positive and negative of the same number, so you have to be careful and not get in the habit of thinking that automatically when you find one answer, the other answer is the negative of that. Here, the answers are 9 and 15, and those are not the same numbers. So, right, go ahead and get down number 5. X squared equals negative 49. All right, so again, if I'm looking at this, there's nothing in front this time that needs to be moved. It's just the x squared, so we can go ahead and take the square root of both sides. Okay. Now here, my square root cancel, so I'm just left with x. But this other side's a little bit tricky here. If you try putting in the square root of negative 49 in your calculator, it's going to tell you non-real answer, okay, or error. The reason for that is because we can't take the square root of negative numbers and get a real solution. So when we take and we see this negative right here, we're going to know that we're going to have imaginary solutions. Now, we're not going to work a whole lot with imaginary numbers, but here you should know that I squared equals negative 1, and I is the square root of negative 1. So here again we have what's called an imaginary number, and the reason they came up with this is so that they could deal with the square root of these negative numbers. So all you need to know is that whenever you see the square root of a negative, it's just going to be a little bitty I for imaginary. That little I gets rid of that negative inside that square root, and then we can just take the square root of 49, which is 7. So we have positive and negative 7I. And that I again stands for an imaginary number since we had the square root of a negative. So my answers are going to be negative 7I and positive 7I. So I don't have real solutions, we have imaginary ones here. Go ahead and make sure you have that copied before you move on. Okay, let's look at the check for this one. If I have negative 7I squared equals negative 49, then here, if I square the negative 7 and I square the I squared, 7 squared is a positive 49, but I squared up here, one of our things with imaginary numbers, if you square the I, you get a negative 1. So 49 times negative 1 is negative 49. So that checks out. And we're only going to do this one part of the check because it works exactly the same way if you have a positive 7I. Please make sure you have the answer in that part of that check written before you move on. All right, number 6 is x squared equals 0. This one's super duper easy. Again, to get rid of the squared on the x, we take the square root because squaring and square rooting are opposite operations. Positive and negative square root of 0. Well, here we have x equals positive and negative square root of 0 is 0. Here you can't have a positive and negative 0, so my answer is just 0. Go ahead and make sure you have number 6 written before you move on. Right, go ahead and write down number 7. Number 7, x squared equals 15. Again, to get rid of the squared, we're going to take the square root of both sides. Again, remembering our positive and negative version. It's the hardest thing to remember about this lesson. We get x equals positive and negative. And here, if we put in the square root of 15, I come out with a decimal because 15 is not a perfect square. And that's okay here. We're just going to round to the nearest hundredth. So since if your answer is not a perfect square, you're just going to round to the hundredth. So we're going to say 3.87. And if you look at this, if I'm rounding to the hundredth, that means 2 decimal places. So I'm looking at that third one, that 2, which means that 7 is going to stay a 7. It's not going to go to an 8. So we're going to write our answer in our squigglies as negative 3.87. and positive 3.87. going to come over here. I want to show you the check because anytime we have to round like that, our check's not going to be exact. So if I say negative 3.87 squared, now I'm going to change this to approximately 15, because in my calculator, if I say negative 3.87 squared, I'm going to get 4.9769, which is going to be, we're going to say 14.98. Again, since we rounded, since the 4.9 is close, very, very close to the 15, we're going to say that that checks out. Same thing with the positive 3.87 squared. We're going to get 14.98 here too. Again, since it's very close or approximately 15, we're going to say that it checks. So anytime you have to round, your check's not going to be exact. Please make sure that you have the work and the check written before you move on. All right, go ahead and write down number 8. Number 8 is 3x squared minus 51 equals 0. This time, since the 3 and the 51 are not being squared, only the x is being squared, we have to move the 51 and the 3 first. So first thing we do is move the 51. It's minus 51, so I'm going to add 51. So I get 3x squared equals 51. Then I'm going to divide both sides by 3, and I get x squared equals 17. And this time when I divided, I got a pretty number, so I'm not going to leave that as a fraction. So here I'm going to go ahead and now I can take the square root of both sides. My squared and my square root cancel, and I'm left with x equals positive and negative square root of 17. So we're going to look at the square root of 17. So we're going to say square root of 17. And again, 17 is not a perfect square, so we're going to end up with a decimal. Again, we're going to round that to the nearest hundredth, so it's going to be 4.12, because again, the 3 next to the 2 leaves the 2 a 2. And our answers here are going to be negative 4.12 and positive 4.12. I'm going to show you the check right here with this one right fast. We're going to say 3 parentheses negative 4.12 squared minus 51 equals 0. And we're just going to make sure that that works. 3 parentheses negative 4.12 squared minus 51. It's going to give us approximately negative 0.08. Which again is very, very close to 0, and again it's going to be approximate if we're having to round. Again, and it'll work the same way if I plug in the positive 4.12. So I won't make you write the second part of that check, but please make sure you have the work and the first part of that check written before you move on. All right, number 9 is a little bit different. Number 9, our directions say solve the formula for r. So we're going to solve this formula for r, and this is a equals pi r squared. And when it says solve for r, all that means is get this r by itself. Right now the a is by itself. They want the r by itself. So we're going to look at the r and we're going to say what's around the r. Well, 1, the pi is in front of the r, and the r is being squared. So we have to move the pi and the squared. We're going to move the pi first since it's not being squared. So we're going to divide both sides by pi, just like we would if it was 2r squared. We would divide by the 2. We're going to say a equals pi, or a divided by pi equals r squared. And then again, we need to get rid of the squared, so we're going to take the square root of both sides. So we're going to say r equals the square root of a over pi, and the r is by itself. Here we don't have to take into consideration the positive and negative version because we know that this formula has to do with circles. So it's the real world version here, and we know that a radius and an area cannot be negative, so we don't have to take into consideration that negative version here. Area is positive and pi is positive, so there's no reason to put the positive and negative sign here. Go ahead and make sure that you have number 9 written down before you move on. All right, we have 2 more real world examples that we'll do in class tomorrow, but this is the end of your video. Thank you for watching.